Hi, welcome back to my channel, Physics Form 5 KSSM. We continue 2.3 gas pressure. So in this video, I will discuss two learning standards. The first one to determine gas pressure using a manometer. The second one is to solve problems involving gas pressure in daily life. This is an instrument that can be used to determine gas pressure. A manometer. A manometer consists of a glass U-tube containing colored water. Just a plain water, so you just add color. Whatever color that you have, red color or green color. This apparatus is used to measure gas pressure. This is the lab instrument to measure gas pressure. There is a more practical way. We call it manometer. So you can see this is a U-tube, consists of a liquid inside. So this one is colored water. Initially, before you connect this U-tube to any source of gas, both level on both arms of the U-tubes are open, meaning there is an action of atmospheric pressure on both of the arms of the tubes. So you can see the level of water in both arms are equal. Why? The level become equal because both level experience same value of atmospheric pressure. Now look at what happens when we connect to a gas supply. You can open the tap for the gas, so the gas will be released out. What happens to the level of water in the U-tube? As you can see here, the gas pressure will push down this level to point A, and on the other arm, the level will rises about H centimeter. So the difference in height of water level is equals to H. So at this opening, so you can see this one open to surrounding air. Thus, there must be atmospheric pressure. So what we can say about the gas pressure? How do you determine the gas pressure? As you can see, the gas acts at point A. Thus, pressure of the gas is equals to pressure at point A. How can we determine pressure at point A? We use the concept of pressure in liquids. For same level of liquid in the same liquid, A and B will have same pressure. So meaning pressure at A equals to pressure at B. Or we can say pressure of the gas actually equals to pressure at B. What is pressure at B? Okay, we go back to what we have discussed earlier. Pressure at point B is caused by weight of liquid above the points. We have H centimeter of liquid. And because of above here, there is surrounding air, meaning atmospheric pressure is also exerting pressure on the surface of water here. Thus, the pressure at B is caused by atmospheric pressure plus H centimeter of water. So to determine pressure of the gas, we can use this formula. Pressure at A equals to pressure at B, and pressure at B equals to H centimeter of water plus atmospheric pressure. As you know that pressure also can be stated in metric unit, centimeter of water or cmH2O, or meter of water. Thus, we can use this unit, okay, to represent pressure due to water. Look at this activity 2.5. You can refer to your textbook. The aim of this activity is to determine the pressure of a gas using a water manometer. Apparatus required is a manometer or U-tube, rubber tube, or we can use silicone tube, half meter rule, 10 milliliter of plastic syringe, water and red coloring. So you can use any color. Okay, so the setup of apparatus is like this. Make sure the U-tube is vertically upright. Here we put a meter rule so that easy we can measure the difference in level of colored water in the U-tube. And then this is a rubber tube. Then at end of this rubber tube, connect to plastic strings. Okay, so you can see once you push the piston or you lower down the volume of air in the string, what happens to the level of colored water? So you can see there will be difference in level of colored water, that is H centimeter of water. Okay, let's watch this video so that you will understand this topic clearly. So this is a U-tube, consists of colored water. We put a meter rule so that it can measure the difference in level of colored water. Before you attach to the tube to a string, make sure level are same, both arms of the U-tube. So initial volume we can set at certain value. Okay, you can record 5 set of data. Okay, push the piston slowly to a certain value of volume. For example, initially maybe 8 millimeter. So you can see the level of water in the tube change. Okay, so what you do, you just measure the difference in level of colored water. Once you remove the string, you can see the level go back to the same level. Why? So you can see at this end here is open to surrounding air, meaning there is atmospheric pressure. And the tube here is also open to the surrounding. Thus the pressure here and here are the same. Then the level become equal. Okay, so you can repeat the step by pushing the piston to a lower volume. Look at what happens to the difference in level of colored water when the volume decreases to a certain value. So we can read the difference in level of colored water by using the meter rule, and then we can record the reading in the table. So the pressure of the gas in the string actually is caused by H centimeter of liquid or water, that is a difference in level of colored water, and atmospheric pressure. So you can continue with the smaller volume. Let's say we increase the size or the volume of the air in the string, so you can see what happened to the level. This side will rise up. Okay. Okay, this one shows that when increase the volume of the gas, atmospheric pressure will become higher than the pressure of the gas in the string. It's just like a competition. So this one shows that atmospheric pressure win the situation. So when this happens, we can say that atmospheric pressure is higher than pressure of the gas. Same thing in what we already shown before. If you compress it or press it, for this side, you can see the gas now is winning the competition. Meaning that the gas pressure is higher than atmospheric pressure. That's why the gas able to push down the level lower compared to the other side. Okay. So this case, atmospheric pressure is higher. For this case, gas pressure is higher. Okay, so from here, we can determine the gas pressure. Okay. So what we do, we just record 5 set of data for different volume of gas in the string. Then we can make analysis based on the data recorded. Okay, the procedure of this activity is the first one, push the piston slightly into the string until the reading of 8 milliliter. Determine the height h between water levels in both arms of the U-tube. Calculate the air pressure in the string in meter of water. Use atmospheric pressure 10 meter of water. Repeat steps 2 and 3 with readings of 6 millimeter and 4 millimeter on the string. So you can repeat until you can get 5 set of data also can. So the table here shows for 8 milliliter of the reading on the string. So the height or difference in level of colored water equals to 6 centimeter. So this one we change to meter. So equals to 0.06 meter. So for 6 milliliter, we get about 10.5 centimeter. So this one equals to 0.105 meter. And then for 4 milliliter equals to 15 centimeter. So it's equals to 0.150 meter. So what is the air pressure? We have discussed before. The air pressure is equals to what? Okay. So the air pressure here is equals to atmospheric pressure plus H meter of water. So atmospheric pressure for the first one here is equals to 10 meter of water plus 0.06 meter of water. Okay, because of the height is in meter, so we can write the we can write the pressure due to water as 0.06 meter of water. That's the total become 10.060 meter of water. So for this one is 10 meter water, which is atmospheric pressure, plus 0.105 meter of water. So this due to water, So total up, we get 10.105 meter of water. And then for 4 milliliter, the height is 0.150 meter. So the total pressure of the air is equals to, or air pressure in the string equals to 10 meter of water plus 0.15 meter of water. So we get 10.150 meter of water. Okay. So discussion, how can the value of air pressure from this activity be stated in Pascal? So the unit used here is metric unit meter of water. So to calculate or to change the unit to SI unit Pascal, so we can use the formula P equals to H rho G. So we are going to use the value that we get from this activity. So the total pressure in meter water is equals to difference in level of colored water or height between the water levels H plus atmospheric pressure equals to 10. Thus it becomes the formula H plus 10 multiply density of water, because we use water, G 9.81. So we just can substitute the value of H. Let's say for the 8 milliliter, we get 10.060. So we just substitute here. 10.06 times density of water 1000 multiply 9.81. Thus we get the answer in Pascal. So by using this method, okay, by using this formula. Okay. Number 2, suggest a suitable liquid to be used in the manometer for measuring higher gas pressures. Okay. So if we use to measure higher gas pressures, so the difference in level of colored water will rises very high when there is a change in the density, especially greater change in density of liquid. Okay, so if we use water, so a small change in the gas pressure will cause the height between the water levels to increase very high. So for gas pressure, is not for higher gas pressure, it is not suitable to use water. So we need to replace with higher density of liquid, such as mercury. Because for denser liquid, mercury, the greater change in the density of gas will produce smaller change in height between the water levels. Thus, we can increase or we can increase the accuracy to measure, or we can use a manometer which is shorter and suitable to be used practically. Okay, so the most suitable liquid that can be used is mercury due to higher density. Okay, let's try to solve problems in daily life involving gas pressure. There is a mercury manometer connected to flask with compressed gas. Atmospheric pressure given 76 cm mercury. Density of mercury given 13,600. And gravitational acceleration G is 9.81. What is the pressure of the compressed gas in cm mercury? So you can see when you open the tap of the gas here, the gas will be released out, then push this level down. Okay, meaning pressure of the gas equals to pressure at point E. How to determine pressure at point A? Remember what we have discussed before. Same level, same liquid, same pressure. Thus, pressure at A equals to pressure at B. What is pressure at B? What we have above point B. Above point B, this one is open to surrounding air, so there is atmospheric pressure. And then above point B, there is 40 centimeter of mercury. Thus, the pressure of the compressed gas in cm mercury is equals to H plus atmospheric pressure, meaning 40 plus 76. So you can add directly, because this one is mercury, and the unit for atmospheric pressure is also cm mercury. So we can just straight away total up. So we get 40 plus 76. So this 40 cm is due to the mercury, and another 76 is caused by atmospheric pressure. So the total will become 116 centimeter mercury. So this is the unit that can be used for a manometer which uses mercury. So this one is normally for high pressure of gas, so not suitable to use water. So we replace it with mercury. Okay, calculate the gas pressure in Pascal, meaning convert the unit to SI unit. Okay, so use the formula H rho T. Look at the formula here, cm mercury. So when you want to convert to Pascal, Pascal is equals to Newton meter to the power -2, which is SI unit. Thus, the length here, 116 centimeter, you need to convert to meter. So it becomes 1.16 meter. Because of this one is mercury, so we need to use density of mercury, 13,600. And the value of G is 9.81. So you just multiply, so you get 1.55 times 10 to the power 5 Pascal. Okay, so this is how you convert the units. So just straight away use the formula H rho G. Because of here is mercury, you use density of mercury. Okay. C. Will your answers in A and B change if the glass tube or manometer has larger diameter? Remember what we have discussed before in pressure and liquids. Okay. Okay. No change because pressure and liquid and atmospheric pressure does not depend on area or shape of the tube. So it remains the same. Okay, let's discuss another example on this one. Example 2. A mercury manometer used to measure pressure in airflow pipe. What is the difference between air pressure in the pipe and atmospheric pressure in cm mercury? Okay, so you can see the level, difference in level is 25 centimeter. Okay, there's a difference in pressure for both sides or both arms of the U tube, so you can see. Okay, so height of mercury column equals to 25 centimeter mercury. So if this one is already in mercury, so straight away we can use the unit cm mercury. Okay, so 25 cm mercury. How about B, atmospheric pressure? Atmospheric pressure is 75 cm mercury. What is air pressure in the pipe in Pascal? Okay, now we want to find the air pressure in Pascal. So the air pressure in the pipe is equals to total pressure. Pressure due to mercury, 25 cm mercury. And because of this arm is open to surrounding air, there is atmospheric pressure. If this one closed, atmospheric pressure is equals to 0. No atmospheric pressure. But this one is open, so there is atmospheric pressure. So the total pressure equals to H plus atmospheric pressure. So the H here is 25 centimeter plus atmospheric pressure 75 centimeter mercury. So you just can add directly because the unit are the same. Okay, so we get 100 centimeter mercury. Now you want to convert to Pascal because the instruction here must write in Pascal. So use the formula H rho G. What is H here? 100 cm convert to meter, become 1 meter. This is mercury, so we use density of mercury, 13,600 times G, 9.81. Thus we get 1.33 times 10 to the power 5 Pascal. So this is the pressure in the pump. Okay, because of this point or this level, push down causes this level to rise up, meaning pressure here is higher than pressure at this point, or greater than atmospheric pressure. So you can look at the value here. Okay. For method practice 2.3, look at number 1. Figure shows water manometer connected to flask containing gas. A. Compare the gas pressure in the flask with the atmospheric pressure. So look at diagram here. You can see this level is pushed down lower, meaning the gas now is the winner, or the gas has higher pressure than atmospheric pressure. So we can write the answer. Gas pressure in the flask is higher than the atmospheric pressure. B. State the difference between gas pressure and atmospheric pressure. So the difference is the 36 centimeter of water. Okay, difference in level of water. So this one we convert to meter, thus it becomes 0.36 meter of water. Calculate gas pressure in Pascal. This is the difference in the between the gas pressure and atmospheric pressure is the pressure due to water at this point. Okay, when we talk about gas pressure, is the total pressure above this level, meaning there is atmospheric pressure and 36 centimeter of water. So what we do, we need to total up. So we add 0.36 plus 10.3. This one is given. 10.3 meter of water is atmospheric pressure. Meter of water, so equals to 10.66 meter of water. The required unit is Pascal. Then we use the formula H rho G. What is H here? 10.66 meter, already in meter. Then this one is water. Then we use density of water. G 9.81. Thus we get 104575 Pascal. So you can write the answer also in standard form, meaning it's equals to 1.05 times 10 to the power 5 Pascal. Okay. Number 2, what are the advantages of using mercury manometer compared to water manometer? Mercury manometer can measure higher pressure because mercury is denser liquid. So it does not need a very long tube. Rate of evaporation of mercury is lower than rate of evaporation of water. Okay. So the amount of mercury no need to always added from time to time. Okay, because the rate of evaporation is lower. Number 3, mercury manometer is connected to steel cylinder containing compressed gas. The pressure of the compressed gas and atmospheric pressure are 180 kilopascal and 101 kilopascal respectively. Calculate difference in height between two mercury columns in the manometer. The difference, okay, actually is the difference in height between two mercury column. So you just take 180 minus 101, so it becomes 79 kilopascal or 79,000 pascal. So how many centimeters? So meaning we need to convert the unit from pascal to centimeter of mercury. So we use the same formula H rho G. Let's say the difference in height is H. Density of liquid is mercury. G is 9.1 equals to 79,000. Thus we get H equals to 0.592 meter. Convert to centimeter, become 59.2 centimeter. Thus the difference in height of two mercury columns in the manometer equals to 59.2 centimeter. Okay, that's all for our topic today. It's about gas pressure. So you can do more exercise on this so that you can understand better. So I will stop here. Bye.